Let's see what are the three things they will definitely ask at the Chemical Kinetics exam. First thing they will ask in the paper is about finding rate law using experimental data. This is a very common question. You might get an MCQ or a structured question. Before going for the question, we'll understand what are the basic things you should know to solve these questions. First of all, I would like to tell I'm not talking about the deep chemistry here. I just try to remind you the things which you are supposed to know. So here they are talking about something like rate law. What is rate law? Rate law means it's an equation which represent how change in concentration of each reactant affect the rate of the reaction. For an example, let's take an example. Here we have reactant A. These red color simple letters are the stoichiometric ratio. We call them molar ratios. Reactant A reacts with reactant B, giving you C and D. C and D are our products. And this rate, the speed of this reaction is mainly depends on concentration of reactants. There are other factors also. Those factors are hidden inside this rate constant. For now, we are talking about how this rate affect by the change in concentration of both A and B. And how they affect on the rate of the reactions are different because they have different reactants have different effect on the rate of the reaction. So therefore, for each concentration term, there's a power. This is A to the power X. This X we call it order with respect to the concentration of A. It says that if you increase the concentration of A, let's assume you double the concentration of A. Sometimes when you double the concentration of A, rate will not change. There are some reactants like that. So to show that rate does not change, that means this order X has to be something like 0. 2 to the power, let's take A is 100. 2 to the power 100 means 200. 200 to the power 0 means still 1. So it doesn't matter what is the number you have as a concentration, is all answer will be always 1. So therefore change in concentration of A does not have any effect on the rate of the reaction. Likewise, when you change the concentration, this power tells you how they affect the rate of the reaction. So rate law simply tells you rate equals a constant time, we call it rate constant, multiplied by the concentration of the first reactant to the power X. X is the order with respect to that reactant, times concentration of the second reactant to the power Y. If you have a third reactant, it will be concentration of the third reactant to the power Z. That's how you write the rate law. So our job here is to find these orders X and Y. So without wasting time, let's see what are the things we have to remember. Now we know how to write a rate law. So these orders has some values. So they can be 0, they can be 1, they can be 2, they can be 3, likewise. They won't go more than 2 or 3, right? Because the reason is there's a science behind it. So we'll discuss those parts when you're discussing about the lesson. So what you have to remember here is if your order is 0, nothing happens to the rate. It doesn't matter when your concentration doubles or triples, nothing happens to rate because anything to the power 0 is 1. But when you double the concentration, if rate also doubles, that means the order is 1 because 2 to the power 1, 2 is the concentration. You double the concentration 2 times, 2 to the power 1 is 2. So rate will also doubles. Third thing you have to know is when the concentration, if you double the concentration, if the rate increases by 4 times, that means 2 to the power 2 is 4. So when you double the concentration here, that doubling times 2 to the power 2 will give you the answer 4. So that means order with respect to that reactant is 2. So if the order is 0, even you double the concentration, nothing happens to the rate. If the order is 1, when you double the concentration, rate will also doubles. If the order is 2, when you double the concentration, rate will increase by 4 times. Let's see what are the types of questions you will get. So this is the first type of question you will get from this is Chemical Kinetics, this lesson Chemical Kinetics. Okay, we have an example question. This question about nitrogen monoxide. Nitrogen monoxide react with oxygen to form nitrogen dioxide. Some initial rate data are shown. So they have given a table. So they have given experiment 1, and what was the concentration nitrogen monoxide and what was the concentration of oxygen, and then they are saying what was the rate at that point. Now they say that looking at this experimental data, deduce the rate equation and justify your answer. We'll write the rate equation first. So I know the rate equation means rate, or we call it rate law. Rate equals a rate constant time concentration of the first reactant, which is our nitrogen monoxide, to the power, is it 2? No. This order and this molar ratio can be two different values. They might be the same, sometimes they might be different. So we call it to the power x, we don't know. And the second reactant is concentration of oxygen. We don't know its order also, to the power y. So here they ask us to do is finding this x and y. For that, we have to look at this data table. When you look at this data table, can you see in the experiment 1 and experiment 2, the concentration of nitrogen monoxide remains unchanged. Can you see that part? Concentration of nitrogen monoxide remains unchanged. Even though the concentration of nitrogen monoxide remained unchanged, can you see that concentration of oxygen? So we can see here, concentration of oxygen start from 0.001 and turn into 0.002. Can you see concentration of oxygen doubled? When the concentration of oxygen doubled, what has happened to the rate? 0.00802 became 0.01604. If you divide it, you can see it's also doubled. Concentration doubles, rate doubles. What was the order? Order is 1. So first I am writing as what we discussed earlier. So first what I am going to write here is, now I have write that point here. So I'm just writing like this. Let's write a sample answer. We check with the marking scheme. So I write, when consider experiment one and 2, concentration of oxygen doubles while concentration of nitrogen monoxide remains constant. And rate doubles. Therefore they say that x concentration of oxygen doubles while concentration of nitrogen monoxide remains constant. So when the concentration of oxygen doubles, rate also doubles. So is the order with respect to oxygen is y. So therefore we can say that y is 1. Therefore order with respect to oxygen is 1. Okay, let's see how we can find the order with respect to nitrogen monoxide, which is x. Can you see here, experiment 3 and 2, concentration of oxygen remains unchanged. These two are remaining unchanged. And the concentration of nitrogen monoxide, I increased by 4 times. When I increase by 4 times, rate, let's divide. So 0.25664 divided by 0.01604. So you can see answer is 16. That means rate has increased by 16. We know what is 16. 16 is 4 squared. Therefore we can write, when consider experiment 2 and 3, concentration of nitrogen monoxide. We are going to make it concentration of nitrogen monoxide increase by 4 times. Nitrogen monoxide increased by 4 times, while concentration of oxygen remains constant, and rate increased by 16 times. Therefore, we can say that since 4 to the power 2 is 16, so therefore order with respect to nitrogen monoxide is 2. So therefore we can say that x equals 2. And when you consider these two, then we can write the rate expression. So rate expression is rate equals rate constant time nitrogen monoxide concentration to the power 2 and oxygen concentration to the power y. Okay, using this data, now let's see whether our answer is correct. Okay, let's go to the next slide and we'll figure it out whether we wrote the right answer. So it says, okay, so this one says an answer that makes the reference to the following point. Experiment 2 compared to 1, concentration of oxygen doubles while nitrogen monoxide remain constant and the rate doubles. Yes, we said that part. When the consider experiment 1 and 2, concentration of oxygen doubles while the concentration of nitrogen remain constant and the rate doubles. Yes, we mentioned that part. Experiment 3 compared to experiment 2, multiplying concentration of nitrogen monoxide by 4 times results in increase in the rate by 16 times. Yes, we wrote that point also. Then first order with respect to oxygen and second order with respect to nitrogen monoxide. Yes, that's what we said. X equals 2, y equals 1. Because we have mentioned what are x and y, so you'll get marked for that one. Then the final rate law. Yes, we get full mark for that answer. Okay, next one. They are saying calculate the rate constant for this reaction, include your answer. Okay, so now they ask us to calculate the rate constant. To find the rate constant, what I'm going to do here is I'm going to use this experiment number 1. So this first experiment. So we have their data. So NO2 to the power 2 and O2 to the power 1. Okay, we'll use that data. Okay. So when we go for the rate law, so we know that rate equals rate constant time nitrogen monoxide concentration to the power 2 and O2 concentration to the power 1. Okay, this is the other part they will ask. First they will ask you to get the rate law and rate law equation, and then they will ask that use that equation to calculate the rate constant. So rate is there. If I use the data test set, first data, it is 0.00802. It's better to write the units because the reason is here is they not only want the answer, they want your unit as well. So if you do this one, so rate usually comes in moles per cubic decimeter per second, because rate means simply concentration change over time. No, concentration time change is moles per cubic decimeter, time is per second, equals rate constant. We don't know the rate constant, that's what we have to find, times concentration of NO. Concentration of NO comes 0.001, unit is moles per cubic decimeter to the power 2, because there's a power 2 here. Order with respect to nitrogen monoxide concentration is 2 times concentration of O2 0.001 moles per cubic decimeter to the power 1. So therefore I'm gonna put anything there. Okay, now we have to find the rate constant. So we'll make rate constant as a subject. So if I take rate constant as subject, you have to take all these values to the other side. So what I'm going to get here is 0.00802. On top I will have moles per cubic decimeter per second. This whole thing divided by 0.001 squared. So I'll get 0.001 squared, and the unit also gets squared. So mole will get squared, it will be mole squared. So I'll just write like this: moles per cubic decimeter times moles per cubic decimeter. This thing multiplied by again by 0.001 moles per cubic decimeter. And we can see that this unit and this unit we can cancel out. Moles per cubic decimeter to moles per cubic decimeter. Then when I do the simplification, I'll get the answer rate constant as 8.02 into 10 to power 6 the unit will be moles, so unit will be something like this. Per second will remain on the top, and in the bottom we'll have moles times moles is mole squared. dm minus 3 times dm minus 6 is dm minus 6. If you take them up and write them together, mole squared comes out, it will be mole minus 2. It will be mole minus 2. dm minus 6 comes up, it will be dm plus 6 and per second. The bottom one is gone, so this is our answer: 8.02 10 to power 6 and mole minus 2 dm6 per second. Okay, that will be our answer. Let's go to the marking scheme and check. Yes, 8.02 10 to power 6 mole minus 2 dm6 and per second. Yes, that's our answer. Okay, so that will be an easy one. So that's the first type of question you'll get. So there are one definite question that you'll get here is about finding the rate law. They will give you an experimental set of data, and using those experimental data you'll have to find the order with respect to each reactants, and then you'll get the rate equation. And using the rate equation, the next definite thing what they will ask you to do is to find the rate law, and from that they will ask you to find the rate constant with units. That's a definite question. The second definite question you will get from this rate of reaction is predicting the reaction mechanism, right? What is this reaction mechanism? There are 2 points that you have to remember when you talk about this reaction mechanism. First thing is, basically reactants which are participating in the reaction will appear on the rate law equation. Yes, obviously we know that on the rate law equation the concentration of reactants are the one we are talking about. We are not talking about anything else. So reactants are the ones, their concentration are the ones which are appearing in the rate law expression. Second thing is, the order with respect to each reactant will represent the number of molecules which participate on the slowest step of the mechanism. That little bit tricky, right? Let's try to understand using an example. We'll take a day-to-day life example. Let's assume they say that in a rate equation, if the orders with respect to each reactants are same as the molar ratios, such reactions are called single step reaction. What's the meaning of this one? Let's go and figure it out. Let's take your parents are going on a journey, right? They are going for a trip or something, and they are going to leave you alone at home. In the refrigerator, they are going to store some food for you. They are going to pack 2 fried rice. There are 2 packages, 2 boxes of fried rice and 2 boxes of pizza and 1 burger. So they expect you to use this food to survive yourself for 3 meals: breakfast, lunch and dinner for the day. Okay, let's assume you woke up early in the morning. You are so hungry, so you ate 2 fried rice. So they are gone. But you are still hungry. Let's take you eat the 2 pizzas also. They are also gone. You are still hungry. You eat the last burger also. So if you use all the food at breakfast, there won't be anything left for lunch and dinner. So you will have only 1 meal for the day. Same scenario happens in chemical reactions. Let's take there's a reaction here. In this reaction, we have 2 molecules, 2 A molecules. There are 2 A particles and 1 B molecules. When 2 A molecules and 1 B molecules collide with each other, you get 1 C molecule, which is our product. And the rate law tells rate equals rate constant time A to the power 2. Can you see? These 2 particles are there, A to the power 2. B to the power 1. Can you see? It's 1 here and 1 there. Molar ratio and the orders are same. What does this mean? Actually, can you remember we learned that? I'll just go back and show you that slide. Here we learn the point. The orders with respect to each reactant will represent the number of molecules which participate in the slower step of the mechanism. If you take a mechanism, there can be many steps. There can be fast step, there can be slow step. So what they are telling here is, in a mechanism, there's a slower step. No, the slower step has certain number of molecules taking part. The slower step has certain number of molecules which are taking part in the mechanism. So what they are saying here is, the order is responsible for the number of molecules taking part in the slower step of the mechanism. So what they're saying here, that if this is 2, that means there are 2 particles of A taking part in the slower step. If this is 1, that means the number of molecules of B taking part in the slower step is 1B. The interesting part here is, in the reaction you have 2 A molecules. All those 2 A molecules taken part in the slower step. In the reaction you have only 1 B molecule. That 1 B molecule is taken part in the slower step. That means you have used all your reactants in the slower step. If you use all your reactants in the slower step, there can't be any other steps, because the reason is you have used it completely. Just like you ate your whole food within breakfast. If you eat whole food within breakfast, there won't be any other meals, right? There won't be any other lunch, there won't be dinner, because the reason is you don't have food. Same thing, they say that if a reaction has a certain number of particles, and if all of them are used up in the slower step, how do I know that they have been used up in the slower step? Because the orders tells us how many particles used up in the slower step. If all of them used up in the slower step, then there can't be any other steps. That's why we call them single step reactions. Let's take a different scenario. What about if it's not like this? Again, I have a different mechanism. I have 2 A molecules, 1 B molecules. Now how much you have in the reactions? 2 A particles and 1 B particle. Okay. Rate law tells you how many particles you have used at the slower step. Okay, I'll write this step 1 is my slower step, this is my slower step, right? Rate law tells me I have used only 1 molecule of A in the slower step and 1 molecule of B in the slower step. Even though I have 2 molecules of A in the reaction, I have used only 1. So 1 molecule of A with 1 molecule of B cannot produce the product C, because C need to produce C, I need 2 molecules of A combined with 1 molecule of B. So that means what I am going to get is not the product. So if you don't get the product, we call it intermediate. If someone asks you what is the formula of intermediate, intermediate is simply a mixture of A and B. So you call it AB. Okay, that intermediate, that means you can't produce the products in the first step. So that means there has to be a second step. But the second step is going to happen. This AB mixture will react with the remaining A molecule, because I had 2 A molecules. I only use one. Remaining A, inside this there's AB. AB react with the remaining A gives you C. Why is that? When two A molecules combine with one B molecule gives you C. Simply what they are saying here is, if your molar ratios and these orders are not matching with each other, that means such reactions should have to have more than one step. They have more than one step. Right. This is the type of question, this concept they will use in the exam to check whether you can design a mechanism of a reaction. Okay, let's see. The reaction of nitrogen monoxide with oxygen is thought to be a two-step reaction mechanism. So I need to go through that rate law again. What was the rate law we found? Okay, NO to the power 2 and NO2 to the power 1. Okay, so we'll write the rate law in the corner. Okay, so my rate law says that rate equals rate constant time NO to the power 2 and O2 to the power 1. Okay, so what was the reaction? I'll write the reaction also. Nitrogen monoxide turning into nitrogen dioxide after reacting with oxygen. So if I balance the equation, so there has to be 2 here. 2 times 2 is 4, 4 is there, so 2 is there, so needed 2 more. Okay, this is the reaction. Okay, now I have the rate law. The first step proposed mechanism is shown. Now they have given the mechanism for us. Okay. Then suggest an equation for the second step for the rate determinant step of the mechanism. Justify your answer using the rate equation. Okay. Using the rate equation, you have to justify the answer. Okay. So what I'm going to do is, first I'm going to write the complete equation. So I'm going to show the equation because the equation was given at the beginning. So I won't get marks, but I'm going to write this equation for me to get an answer, to get an idea what's going on, right? So this is the reaction. Then I write the rate law. So rate law says that rate equals rate constant NO to the power 2 and O2 to the power 1. Right, so I just wrote these two. So then the first step also I'll just write. So mechanism, if I go for the mechanism, so the things I'm going to write in black color is the how I'm thinking. For those things you won't get marks, right? But what happens in my brain. So mechanism has step 1 because what they have given. Step 1 is 2NO gives you N2O2. Now let's start thinking, right? So first thing I know that rate law shows that slowest step equal rate determining step. So first I'm going to say in the slowest step, or we call it rate determining step. There should be an involvement of two molecules of nitrogen monoxide. And why did I say 2 molecules of nitrogen monoxide? Because can you see order with respect to nitrogen monoxide is 2 molecules of nitrogen monoxide, because because it is second order. And one molecule of oxygen. Why? Because it is first order. Right. So that means my rate determining step, it can't be step 1, because step 1 I don't see any oxygen there. So therefore my rate determining step should be step 2. Step 2. Okay, now let's see step 2. I should write it in red color or different color, because that's the one they asked us to do. So this is rate determining step. So this is rate determining step. Okay, now let's see. Okay, so can you see from step 1, 2 NO molecules combines forming N2O2. What is N2O2? N2O2 means actually 2 NO molecules are there. So this N2O2 in step 2. So N2O2 means 2 NO molecules together. They should collide with one more oxygen molecule. Why? Then only I get the product. So 2 NO molecules means N2O2 combined with one oxygen molecule. I should get the product now. Because can you see, to get 2 NO2 I need 2 NO molecules. I have it in the form of N2O2, and when it collides with one oxygen, so because this is equivalent to N2O2, when it collides with one oxygen I should get 2 NO2. Yes, I'll get 2 NO2. That's the rate determining step. Okay, so they're asking justify your answer using the rate equation from A1. Yeah, I think we wrote, because it is second order. Then I have write, why did I take N2O2 as same as 2 NO molecules? I have write it as a point. I write that N2O2 produced from the first reaction on the first step, step represent 2 moles of NO molecules. Yeah, 2 moles or 2 molecules. Yeah, 2 molecules. Yeah, represent 2 of NO molecules. Yeah, 2 moles or 2 of NO molecules. That's enough. Yeah, so it makes sense. Now let's see our answer and check whether do we get marks for this. Don't get marks. Okay, let's see. So they are talking about 3 marks, right? Equation N2O2 gives you O2 with 2 NO2. Yes, we get it. 1 mole of O2 is needed to rate determine step. Yes, we mentioned that 1 molecule of O2 is because 2 moles of NO required for the rate equation are in the first step. Yeah, so N2O2 produced from the first step 2 of NO molecules. Yeah, it represent. Yeah, because NO2 and NO both represent the same thing. Yes, you will get marks. No issues with this one. Right, let's go for next one. Now, the third thing. So we discussed 2 things that they will definitely ask in the chemical kinetic part of the examination. First thing they will ask, they will give you a data table. Using those data, they will ask you to determine the rate law and the orders with respect to each and every reactant. In the second part, we discuss about how they are going to use your knowledge on mechanism to determine a mechanism for a given reaction. They will give some data using the rate law, and the slowest step or the rate determining step, you have to finally deduce the mechanism for the reaction. Third one, they are talking about activation energy, how to find the activation energy of a given reaction. This will be mostly, they will give you a graph, or they will ask you to draw the graph, plot the graph. Based on that one, they will ask the question. Let's go back to the thing that we learned about chemical kinetics. We learned that in chemical kinetics, when you take chemical reaction, rate of the reaction is equal to rate constant time, concentration of the first reactant to the power x, which is the order with respect to the with respect to the concentration of A, and concentration of the second reactant to the power y. Y is the order with respect to the concentration of B. And then I discussed that there are many other factors affecting the rate of the reaction. There are many other factors. But here we can only see the concentration terms, because the reason is the other factors are hidden inside this rate constant. Rate constant means another complete equation itself. Rate constant equal Arrhenius constant time exponential minus EA, that means activation energy, divided by RT. R means universal gas constant, which is 8.314 joules per Kelvin per mole, and T is the absolute temperature in Kelvin. Now, most of the math teachers going to get angry with me, because I'm going to explain what is this, the meaning of this exponential term, because the students who doesn't do maths, they don't understand this one clearly. So therefore I'm just going to use some words which math teachers won't like it, but in the sake of other kids who doesn't understand this concept properly, I just tell them in this way. This exponential and ln thing is like this. Let's assume I have 100,000. So I have 100,000. It's a big number, no? So sometimes plotting these big numbers, dealing with these big numbers are so confusing. So they found a method to how to represent these numbers in a simple way. 100,000 you can write it as base 10 to the power 5. 10 to the power 5 is 100,000. So actually the word meaning of log, taking log means you are writing that number in the base of 10. So 10 to the power 5 now. So when you say log 100,000 means you don't talk about that base 10. You just say is 5. 100,000 means 5. That means when you see any number in log terms, that means they are talking about base 10 to the power something. That power is the one they are talking about. So let's take, I get 3. What is 3? 1000 is 10 to the power 3. So therefore is log value is 3. So if I want to go backward to find the real number, so this is the real number now, what we are talking about. How I'm going to go back to the real number? Just take 3, put 10 there, and now put the power as 3. 10 to the power 3 is 100,000. I'm going back. If going forward is log, going backward we have to have word for it now, because going back from the log number to the real number. We call it antilog. Now mathematicians, they don't have only this log, they have another one called natural log. Natural log, they call it ln. Natural log is ln. In there, the base is a little bit weird. It's 2 point something. It's not 10 or a whole number. It's like 2.718. I'm not sure whether this number is correct, but like something, a 2 point something number. And they put a power. So whatever the number they get, they write it in the form of 2 point something in the base and to the power. That power, just like the log, the power is the one they are going to write here. 1000 means ln 6.91. Because 2.718 to the power 6.91 is 1000. So we don't talk about the 2 point thing, we just talk about the power. Okay, going forward is ln. No? Then what is going backward? If going forward is log, going backward is antilog. Same way, from going this power back to the original number, we can call it anti-ln. But scientists, the mathematicians, they don't call it anti-ln. They call it exponential. So just remember, exponential is something just like log, antilog. Exponential is something ln and exponential. ln you can think in your mind as anti-ln, but don't use that word. That's why I say like most of the mathematician will get angry, but that's a basic way you can understand this concept. Because the reason is, using this rate constant equation, the equation which is hidden inside this rate constant, within this rate constant there's an equation hidden. Using this rate constant equation we can find the activation energy of a given reaction. It's like this. So we have rate constant equals Arrhenius constant time exponential minus E over RT. I don't want this exponential, just let's remove it. How to remove it? This is in my head, I see anti-ln. How to remove anti-ln? Let's multiply by ln. When anti-ln multiplied by ln, anti-ln is gone. The exponential is removed. So what you get? Rate constant will become ln k. Arrhenius constant will become ln a. And we know that multiplication, when you take log scales, the multiplication will become addition. So there will be addition sign. Exponential term is not there, so it will be minus E over RT now. Then what I'm going to rearrange this equation. How I'm going to rearrange it? ln k is same place. ln a I am going to take at the back. Minus E over t I'm going to break in two pieces. Minus E over r first times 1 over t after that. So this is like y equals minus mx plus c graph. You can plot it. If I can find the rate constant, you know how to find the rate constant. In the first question, we found rate constant in different temperatures and plot 1 over absolute temperature on the x-axis and ln k on the y-axis. I'll get a line with a negative gradient and with the intercept, and this gradient of this graph shows me minus E over R. R we know it. It's a universal gas constant. If you know R, we can find activation energy. That's the type of question, next question you'll get in the exam. In this one, they have done everything for you. Can you see? They have found the rate constant for you. And they have done the ln k values also. They have taken the rate constant, ln value of the rate constant also. They have found the temperature for you, and they have done the 1 over temperature, 1 over absolute temperature also. So that means all the y and x axes are given. So 1 over t is x-axis. So x-axis is given here. Y is ln k value. Y is given here. Now they are asking, plot graph ln k against 1 over t and use to determine the activation energy. We know how to find the activation energy is minus E over R. Can you see? It's you get 7 marks for this question, right? It's a very important question. So simply, if you can remember what to plot, they tell that part also. So if you can simply know how to plot a graph, that will give you a lot of marks. So this is how the graph sheets, the graph paper will look like that you get in the exam. So you can say that ln k values are like in the minus negative axis. So it should be below 0. So they are minus values. And then 1 over t temperatures are given. So one thing they will see here is whether you have used more than 50% of the graph paper. It gives you 1 mark, right? So that means you have to have good calibration. So you have to know that how much you have to take from the. So it's better to use the complete graph paper, right? More than 50%. That's the first point they are going to check. Second point they are going to check here is they are going to check whether you have used proper calibration, whether you have marked these points correctly. They will check each and every point. They will allocate marks for it. So they will check that one. Next thing they will check is whether you have marked your axes, whether you have labeled your axis. So remember, inside the graph paper you can use pencil, but this marking, the label in the axis and these calibrations, you should use the pen, right? Remember that one. So using this graph, now is simply you have to find the gradient. You know how to find the gradient. What you simply do is you just mark 2 points So after you plot the best fit graph, let's take you got the best fit graph. So they will go mark for the best fit graph, and you pick 2 points on the graph, and you take y coordinates from there. So these are the y coordinates, and then you take the x coordinates also. These are the x coordinates, and then what you're going to do is, we know that delta y over delta x will give you the gradient of the graph. After you find the gradient of the graph, so let's do it. We found the gradient is minus 13,100. Then what you do is, when you multiply, if you want to find the activation energy, multiply that number by 8.31. You remove the minus sign, because we know that gradient is obviously minus, and your answer is also minus. So you can remove minus sign by multiplying a minus 8.31. Then you get the activation energy in joules per mole. If you divide by 1000, you get activation energy in kilojoules per mole. Those are the 3 basic questions that they will ask from this lesson. What is the first one? Finding the order using the experimental data. Second one, you have to predict using the rate equation, you have to predict the mechanism. Third one, using this Arrhenius constant and the rate constant, and find the activation energy of a given reaction. Those are the 3 things that will save you from chemical kinetic part of unit 4. Likewise, I'll be making different topics. What are the definite questions? Then they will ask each year. Definitely these parts will be tested in the examination. If you go through them, and you will be able to get good marks. Thank you.